Guys, it's the most fear-inducing subject in the advanced level physics and the most dreaded mock Northwest work. It's episode 5, guys. Let's delve in.
Hope you're ready, guys. Let's go.
Okay, guys, so you can pause the video right here and check out the problem, all right? Okay, guys, so the reading of M1, this is M1 right here. Net potential difference across XY. Okay, this is our XY here. So I'll just go ahead and indicate the current direction since the examiner just gave you the diagram without current directions. Okay, so feel free to always indicate your current directions. So I've indicated here that this E1 here is I to the circuit, and I at this particular node splits into I1 and I2. Okay. So we can go ahead and then indicate that this is loop 1, this is loop 2, and then show the examiner in which directions we want to traverse those loops. Okay, so I'll be traversing this guy in the clockwise direction and this guy in the anti-clockwise direction. Okay, so we're going to use Kirchhoff's current law. Okay, apply Kirchhoff's current law in the circuit. So at this particular node, I equals I1 plus I2. Okay, so from Kirchhoff's voltage law on loop 1, of course, if we go to loop 1, notice this, we're traversing like this. So if I traverse like this EMF is positive, so that's E1 there. I'm going like this EMF is positive, this is E2 here, equals sum of the PDs. Now I want you to notice that this will be 5I here, right? So I get my 5I. Now when I traverse and go round, my I2 here, so I'm traversing the direction of this current, so I have 8I2 right there. Now, if I come all the way here, remember that this is I flowing this part of the circuit like that. So it's still I that flows through this 2 ohm resistor. But notice that this 2 ohm is in series with this 1 ohm here. So I'll just add the 2 and then multiply with I, right? Because the same current flows through them. So you have 3I there. Now, we can simplify that equation to E1 plus E2 equals 8I plus 8I2. And then, of course, 8I plus 8I2 will be 20, okay? Because I've added E1 plus E2. E1 is 14, E2 is 6. Okay. So we can go ahead and apply Kirchhoff's voltage law on loop 2, and you notice that, okay, if I traverse like this, E3 here will be positive, so I get a positive E3 there. Traverse like that, negative positive, this guy will be positive E2, and then I go over, and then you notice that we can apply now, we can get the sum of PDs now. So the first would be this 2 ohm, these 2 ohm and these 2 ohm, all three of them are in series, and notice that the current that is flowing through them is I1 and is going opposite to our direction of traverse, so that would be negative 6I1 there. Then when I traverse down this way, I would have 8I2 here. So that's my equation 3. I can simplify and then make it, of course, E3 plus E2 would mean 12 plus 6, which gives me 18. All right, so you can rearrange and then put that like that. So we can put 1 in 2, because notice that equation 2 and equation 3 from Kirchhoff's voltage laws, there's I2 that is common to both. So I cannot touch I2, okay? It's the current that is common to both equations. I can either touch I or I1. I've decided to touch I. So I'll just take this equation 1 and put in equation 2. I is I1 plus I2. So I'll put I1 plus I2 here. And so you notice that this becomes the new equation. And so I get my new equation 4 like that. So I'll take 2 times equation 3. Why? Look at equation 3 here. Look at my equation 4. I have 16I2 here. I have 8I2 here. If I multiply this guy by 2, this equation 3 by 2, I'll have 16I2 here. So I can easily eliminate I2. That's what I'm doing here. So I eliminate I2. I'm now going to be left with just I1, and my constant, my I1 is negative 0.8 amperes. Negative telling me that, hey, this current does not flow in this direction. This E3 here will drift current in the opposite direction, which is okay. So putting I1 in I3, I would have my I2 as 1.65 amperes. And so since I want to get the reading of M1, my M1 would be the voltage across this 8 ohm resistor. Can you see that? And what's the voltage? Basically the resistance of the resistor multiplied by the current through 8, and the current through 8 is I2. So that's why you see M1 reads 8I2. So M1 reads 13.2 because I get my I2 as 1.65. Multiply that with 8, you have 13.2 volts. And so we can go over to Roman 2 that says net potential difference across XY. So how do we get that? Notice I've put down this equation. Let's just talk about how we got this equation. So right here, the potential at X is Vx, okay? So I'm traversing all the way down to Y. So potential here is Vx. If I traverse down, I'll move from negative to positive. This will make this potential to be positive. I'm traversing down again. What would this potential be? The PD drop across this 8 ohm resistor would be negative. Why? Because I'm traversing the direction of current. So I'll have negative 8I2 there to be equals to Vy at the end. So of course I can make this potential as the subject so that I can have Vx minus Vy equals 8I2 minus E2. And so Vxy, which is Vx minus Vy, is just Vxy. It is this. So plug in I2 and then I get Vxy at 7.2 volts. And that is the potential difference between X and Y. Hope you liked it, guys. Let's move on.